In this video, we are going to be solving example 4.5 on page 89 in the AP Physics textbook. This example is called, "That's Quite an Arm." A stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. If the height of the building is 45 meters, A, how long does it take the stone to reach the ground? B, what is the velocity of the stone just before it strikes the ground? So we'll start with our normal problem-solving steps, visualizing the problem. Here is our building. "45 meters tall." And there's a person throwing the ball, but let's just ignore the person. So that's 30 degrees at 20 meters per second. So the trajectory is going to look something like that. Okay. Next, let's figure out our knowns and our unknowns. Oh, and it looks like we don't have to convert anything here. Now, the first thing you want to do, usually with projectile motion problems, is get the initial components of the velocity. So the initial component in the x direction is going to be 20 cosine 30 degrees. And then in the y direction, it's going to be 20 sine 30 degrees. So let's plug those into our calculator. This is going to be 17.32, and this is going to be 10, and that's in meters per second. Part A asks us, how long does it take the stone to reach the ground? So we can write t equals question mark. We also know y final is going to be 0, and y initial is going to be 45. So it looks like to figure out how long it takes to reach the ground, we just want to use the y components because it doesn't accelerate in the x direction, and we're not given how far it goes in the x direction. We only know how far it goes in the y direction. So which kinematic do we want to use for this? We have initial speed, we are looking for t, we have yf, we have yi, and of course we know the acceleration in the y direction. It's negative 9.8 meters per second squared. So it looks to me like we want to use our second kinematic. And remember, when we write our initial speed here, we want to specify that it's in the y direction. So let's plug and chug. And that 10 just comes from our initial component in the y direction. All right, now we have something that looks like we need to use a quadratic equation for. I always like the first term to be positive, so let's just switch this around a bit. If you plug that into a quadratic equation formula, then you should get and obviously we want the positive answer here, so our answer to part A is 4.22 seconds. Don't leave out your units. Make sure you circle your final answer. Okay, part B says, what is the velocity of the stone just before it strikes the ground? So in this case, we're looking for the total velocity, so we need Vfx and Vfy, and then we can resolve those components, put them back together. We know that Vfx is just going to be Vix because there's no acceleration. So that's going to be 17.32. So we're looking for Vfy. And since we just figured out the time, we know the initial speed. It looks like we can use the first kinematic for that. So Vfy is going to be equal to Viy plus At. So Vfy is going to end up being negative 31.356. So if you put that in unit vector notation, you write it like this. So we did just find the velocity. However, the problem doesn't specify whether it wants it in unit vector notation or magnitude angle notation. So let's just do it for both, just in case. So to find the magnitude of Vf, we'll use Pythagoras here. So if you plug that into your calculator, you will get 35.82. And we still want our angle. It's going to be the inverse tangent of the y component over the x component. And that ends up being 61.1 degrees, and we call that below the horizontal. So this would be our answer in magnitude angle notation. So this is an example of a problem where the initial height is not the same as the final height. So I hope you know a little bit better how to do this type of problem now.